project. I am Maya from the NextWork team, and it's so good to see everyone here. Hello, hello. Are you excited to do this project with me? We are working on um, our latest project. We've been releasing 21 projects in 21 days. Isn't that wild? If you're new to NextWork, put a message in the chat. Let us know where you're joining from. What project are you interested in? What do you want to learn? And let me give you the link for this project that we have right here. Super exciting. This is part of our AI CI/CD series. And in this project, we get to find out how we can automate finding dead code. What is dead code? We're going to find out all about it today. Here you go. Good to see everyone here. We've got Sean, Pano, Abdul, Babe, Subiksha, Shane, Honest Hacker, and Nagaraju. Good to see you guys here. Who's doing this project along with me today? Pano, yeah, let's go. All right. Does everyone have the project link on? Let me know if you're having trouble finding the project, but I think we're ready to get started. This is part 4 of a series, and in this series we work with GitHub Actions, and we build a workflow of understanding how AI can help us review code, create tests to automate, and make sure that we take care of what goes out in production and when we push it to Git. And today we're looking at finding out what dead code, automatically find dead code and create GitHub issues with cleanup suggestions. All right. So this seems to be a easy peasy project, 45 minutes, and we are on part 4. What do we need here? We're gonna work on GitHub Actions, um, Gemini API, and static analysis. Exciting. Every NextWork project has a 30-second summary. So if you want to know what the project is all about, if you want to know if this project is right for you, just take a look at what is out there in the 30-second summary, and you will be able to identify and see, okay, is this for me? And if you still have any doubts, you can always just click on the ask, this cute little ask feature that we have. It's like having a buddy right next to you. Ask, tell me about this project. And ask, say, my goal is to be a DevOps AI engineer, and see if this project is a good suit for you. All right, so let's go through the 30-second summary. Tech debt. Ooh, tech debt. Tech debt accumulates silently. Unused functions, dead imports, unreachable code. By the time you notice, cleanup becomes a project of its own. Regular audits catch it early, but who has time for manual code reviews every week? In this project, you build a GitHub Actions workflow that automatically scans your code base for dead code using Gemini, creating GitHub issues with findings every week. Very cool. You can always select anything in here if there's something that you don't understand. If you want more information on tech debt or GitHub issues, it's all right there in this little definitions that come up. Ah, Sean, the link to the project is still locked. All right, so let's give it a minute. Maybe Pano might be on it. Pano, just let me know if and when the project is live. But until then, we can go through the project. What are we going to build today? You build a Python script that scans your repository for stale code and uses Gemini to identify tech debt. The workflow runs on a schedule and creates issues automatically. Look at that. Look at this nice little diagram here. We've got a weekly timer that uh, triggers a GitHub action, and a Python script runs. Gemini reviews the code and then creates new GitHub issues. All right. By the end of this project, you'll have a Python script that scans and runs into the Gemini API for dead code analysis, a scheduled workflow that runs weekly using cron syntax. Whoa, what is cron syntax? Look at that. Interesting. I'm excited to learn more about that. Automatic issue creation with structured findings for your team to review. Categorized findings grouped by type, unused functions, dead imports, unreachable code. And we even have a secret mission, time estimates for cleanup prioritization. Whoa. Are there any prerequisites? Uh-oh. Uh-oh. This is the question. I don't know. How many of you have done all the other 3 projects? While we encourage you to do the other projects in the series, it's not required. All right, we'll find out. We'll find out. Okay, ready? So every project has 3 tracks depending on your style. I like the step-by-step guidance. All right, let's go. Ooh, we start with a quiz. Are you all ready for the quiz? Okay, let's go. In the analyze code with Gemini function, okay, which Python JSON module function is used to convert Gemini's JSON formatted string response into a Python dictionary? Oh. Ooh, do we have any guesses here? Let me know if you have an idea of what function, what Python JSON module function is used to convert Gemini's JSON formatted string response into a Python dictionary. We've got Nick, the Python expert, typing. All right. Let's see what you got. I'm thinking load. What do you think, Nick? Read loads, load or dump. This is also like SAT exam practice skills. You know, process of elimination, load and loads. So we can maybe deduce it's one of these, but the remaining functions don't have a S. So my guess is load. All right. Oh no, Nick says today's definitely not my day. Oh, I'm so glad you said hi anyway. See you, Nick. All right. I'm going to go with load. Back me up here. Ah, that's wrong. JSON load is used to read a JSON formatted file and convert it to a Python object. Okay. So what do we need then? It should be read. Maybe. Shall we try that? Oh. Oh no, how do I go back? Ooh, feature request. Go back on a question. Wouldn't that be nice? All right. Okay, question 2. What does the cron expression 09 ** 1 in a GitHub Actions workflow mean? Oh. A, the workflow will run every Monday at 9 a.m. UTC. B, the workflow will run every hour on Monday. C, The workflow will run daily at 9 a.m. UTC. Or D, the workflow will run at 0 minutes past every 9th hour. All right. Roy says A. Okay. Any other guesses? All right, I'm going to go with A. 09 star star 1 means that workflow will run every Monday at 9 a.m. Oh, look at that. Nice work, Roy. Grown expression is 9th hour on any day of the month, any month, but specifically on the first day, where Sunday is 0. Very cool. Okay, question 3. Why might the stale code detector flag functions in app.py, like add or multiply, as dead code, even if they are used by test files? Oh, interesting. Okay. A, the functions are indeed dead code and are never executed by any part of the application. B, the detector is designed to only analyze Python 2, not Python 3. The detector performs single file analysis and does not recognize cross-file usage. Or D, the detector has a bug that incorrectly identifies all functions as unused. All right, Sean says C. The detector performs single file analysis and does not recognize cross-file usage. Okay. Roy says C too. Okay. Let's go with C. Popular demand. All right. Nice work, Sean and Roy. Well done. Next question. Question 4. How is the Gemini API key securely accessed within the Python script to interact with the Gemini API? A, it is read from a local configuration file named config.ini. B, it is retrieved from environment variables using os environ get. C, it is passed as a command line argument when executing the script. Or D, it is hard-coded directly into the find stale.py. What are we thinking? What do we think? I see that what we're thinking. B? B, Sean says B, 70%. Yeah, I like that it's retrieved from environment variables. Maybe the os.environment.get might be the part we're not sure about. Let's see. Is correct? It's correct. Nice work. So adding API keys into environment variables is a secure way to handle sensitive information. Well done. Question 5. What are the 3 main types of dead code that the detector in this project aims to identify? A, duplicate code, missing documentation, and incorrect error handling. Okay. B, unused variables, redundant comments, and inefficient algorithms. C, deprecated API, security vulnerabilities, and performance bottlenecks. D, unused functions, dead imports, and unreachable code. D, unreachable code. Okay, unreachable code, unused functions. I like it. Let's do D. Yes, it is correct. Yay! 5 on 5. Okay, it's 4 and 5. That's all right. That's all right. But it would be cool if we could see where we went wrong, right? feature request. Okay, what are we building today? In this project, I am going to build a um, a way to find dead code using AI. Huh. This will help me clean up my code effortlessly. All right. Okay, I like it a little zoomed out, but tell me if you can see it. I usually like to see more in my screen in terms of vertical, but I'm also mindful of the fact that you all need to be able to see. So let me know if there's anything I can do to make it better. Okay, step one, find all Python files. In this step, you'll create a Python script that scans your code base for Python files and reads them. Okay, so in this step, you're going to build a function to find Python files in a repository, and then build a function to read all the files you found. Oh, okay, I'm excited. In this step, I'm going to create a Python script that scans my code base. Um, First, I will create a function to find all the files in a repository and then read all the files I found. Okay. Done. All right, so this project continues from the same repo you set up in part 3, AI Test Generation Bot. Completing other projects in the series is not required, so keep going. Okay. Let's make sure that we have forked the AI CI/CD GitHub repository on GitHub and the project cloned locally in Cursor. And that we have our Gemini API key secret configured in GitHub. We'll open the project in Cursor and continue. Before we start building, let's talk about dead code and understanding what dead code is. Dead code refers to code that exists in your code base but never executes. Common types that we'll be looking for include unused functions, functions that are defined but never called, dead imports, modules that are imported but never used, unreachable code, code that can never execute due to logic flow. So that is code after a return statement. Okay. Why does removing dead code matter? Dead code is a maintenance burden. Every line of unused code is code that developers must read, understand, and work around it. It clutters code reviews, confuses new team members, and can even hide bugs. Regular automated audits catch dead code early before it accumulates and causes issues. Okay, what are the 3 types of dead code that will what are the 3 types of dead code that our detector is going to identify? What are they? One, it's the unused functions. Functions. 2 is dead imports. And 3 is unreachable code. Okay. And sounds good. All right. Let's check this out. Wow, look at my documentation. It's coming up already. Nice. Very cool. Yeah, I really like the fun theme. I've tried to play around with the light and the dark, but somehow I always go back to the fun theme. Just makes my day. All right, create the stale code detector script. We're going to open cursor, make sure our forked repo is loaded already. And in our file directory on the left, right click the scripts and then do that. All right. I'm curious, how many of us have completed part 3? I feel like I know the folks who have, but who's doing this project with me from scratch? Let me know in the chat. Let me know. Okay. All right, so let me now open up my cursor. Luckily, I'm already opened up, so I did the first project, and I might have completed parts of part 2. So we'll see how this goes. I have cursor open, and okay, I'm just following the instructions. Let me see if there is a way, if I'm starting from scratch, just to make sure that I have everything that I need. I also just wonder if, let me just check real quick to make sure I have the updated project. 1 second. And let's see. I want to make sure that I see the same things that you see. All right. And do you see my cursor? No. Okay, let me fix that. Whoopsie daisy. Okay, great. All right, let's see. Okay, so I'm setting up the GitHub account. I have a GitHub account. I have cursor, just making sure I have everything I need. I have Python installed. I have the Google API key. I should be good to go. Okay, cool. All right. Sean says, I finished the project with Nat, almost. I finished the secret mission, and I just have to do the very final step. Okay. Nice. It's really impressive, Sean. Okay. Oh. Uh-oh. Uh-oh. All right. Let me really quickly do this again. What am I building today? I'm building a Python script that allows me to detect, detect dead code. This will help me clean up my code effortlessly. Okay. And then what am I doing in this step? I'm going to create a Python script that scans my code base for Python files and reads them. Cool. Isn't this nice, this little navigation to make sure that I have completed all of the tasks? Super handy. The three types of dead code that I'm detecting are 1, unused functions, 2, dead imports, and 3, unreachable code. Let's see. I wonder if the list format comes through here. Let's check it out. Oh, it does. Nice. I like it. Okay, cool. I'm happy with it. No changes needed. Okay, maybe I'll put this away for now. All right, let's now create the stale code detector script. So I'm going to open cursor. Oh, I'm going to have to do a split. Oh, and left. Okay. All right, so on cursor, I want to make sure that my forked repo is already loaded. Yes, it is, because I did the first project. In your file directory on the left, right-click scripts. And in the menu, select new file. And we're going to name it find stale. Okay. Now in the find stale script, I want to scan the code base. So this script is going to scan the code base and use Gemini to identify dead code. We'll build it up function by function. All right, let's add the imports and Gemini client. Let's start by adding the imports. Copy and paste the following into your empty file. Okay, copy and paste. All right, what have I just imported? OS, so import OS lets Python find and read things on your computer OS. You will use it to access our Gemini API key. Import JSON is basically essential for parsing Gemini's JSON responses. Import time, literally time. We'll use it to add delays between API calls to avoid rate limits. Pathlib.path lets Python find and read files in our repo. And then google.genai handles all the interactions with Gemini. We just pass it in our API key. Okay, all right. And what's really cool is that we can always ask more information about each of these. So you can ask and get more information on like what is the time package, what is each of these Python modules for, and you can have a conversation. So it's like having a chat buddy, study buddy right next to you. All right, now let's create the Gemini client. Oh, this is what will allow us to call Gemini later on. Just try filling in the blanks. Do you know how to call our Gemini API key from our OS? Oh, okay. So let me just take a look at this. Create a Gemini client, passing in the API key from the environment variables. So this is where we just add our Gemini key. So I think I know, but give me the answer. I think we would have to go to Google AI Studio, get our key, paste it in. Oh, it's asking for this entire function. Okay, cool. And let me zoom this up. All right, so this is the code we need. Okay. All right, let's copy this code into our file over here. Look at that. Look at that. Okay, so now we're building this file. We're building this Python script together. So we first imported the Python modules, and now we've created a Gemini client passing in the Gemini API key from our environment variables. So, okay. Interesting. Let's keep going. How does this code block work? So this piece, the OS environment get, basically looks up the value of your Gemini API key in your system's environment variables. What are environment variables? Environment variables are like global settings that any program can access. They're commonly used to store sensitive data like API keys, so you don't have to hard code them in your source code. Fun fact, did you know we use get with the round brackets instead of a square bracket because get round bracket returns null if the key doesn't exist rather than crashing with an error. Oh, errors are much better than null because we can react to them more specifically. This makes your code more resilient. Good to know. Nice little fun fact in there. Yeah, that's not fun fact if it errors. True that, Roy. 100%. Well said. Okay, add the file discovery function. Oh, next part. Okay. Oh, look at that. It's already proposing a little function here. No. I'm not going to follow you. I'm going to follow the NextWork project. Okay, add the file discovery function. We want to scan our repo for Python files so we can look for dead code. Let's write the function that does that. So we start with the bare bones. Define get Python files, repo, path, string, and output is a list string. All right. I think from the first few projects, we've learned to identify that this is define. This is the name of the function. This is the name of the input variable. And this is the type of the input variable. The output is a Python object, which is a list of strings. All right. And this is an empty function for now, but it returns Python files, which happens to be a list. Okay, so we're going to copy this. Oh, maybe we don't copy it yet. Okay. We've created an empty function called getPythonFiles. The goal is to take in a GitHub repo folder path and then return all the Python files in that repo. Okay, so this is an empty, we've just defined the Python method, the function. And now what we want to do in here is to take in a GitHub repo folder and then return all the Python files. So we're listing, so what we're going to return is the list of Python files, okay? All right, so how do we do that? Okay, so let's add an empty list to our function. This will store our Python files. Okay, so we had an empty, we just defined the function initially, and now we add this line where we just created an empty list. Nothing, that's it, that's all we did. Python files equals empty list, and that's just initializing the variable Python files. Okay, cool. Finally, we need to look over all the files in our repo and add them to our list. We're excluding any file that we don't need. Look closely. Can you see which ones we exclude? Let's take a look, shall we? All right, so we have a variable for Python files. It's an empty list. And then we have a for loop that goes through path in path repo path dot rglob, and it's skipping. So if any of it has venv.venv node modules pycache git, we continue, meaning that we don't do this, we just go back into another iteration of the for loop. And finally, when we exit the for loop, we return Python files. Interesting. Let's see if there's more explanations on this. Ooh, what's that funky rglob command? That funky rglob command. Rglob is a recursive function. The R stands for recursive, unlike regular glob, which only searches one directory. Rglob searches the current directory and all subdirectories automatically. And the py pattern matches any file ending .py. Okay, so now we paste this code into our existing code. Let's do that. Copy and paste. All right. Whoa, look at that. We're building a Python file together. How's everyone doing? Are we all in the same place? Who's doing this project with me? Roy, Shane, Babe, Abdul? Nice, nice. Nice, same place. Cool. Okay. Now we add the file reader function. Okay, so we have our files. We just retrieved all the files. We've saved all the files that are not venv.venv, pycache, all of these files. So we skip all of those. We've ignored some of them. And then we've saved it all in this list called Python files. But we aren't reading them. We're just retrieving them. Okay, so how do we read them? All right, this is the Python function that is going to read the function, read the files. Okay, let's go through it quickly, shall we? So define read file content. File path is the input, which is a string, and the output is also a string. Read and returns the content of a file, okay? And we have a try catch error handling. Whoa, what are we catching the error? What error are we catching? Okay, what is this code all about? How does this read? All right, so fread is a magic command. Ooh. Can you see where we open a file first? So where's the open? Yep, I see it. Name it as f and then call dot read. Ah, yes. So we're naming it as f and then call dot read on it. It returns the entire file contents as a single string. So the entire file becomes one single string. We've also added if anything goes wrong, like the file doesn't exist, permission denied, encoding error, it catches the exception and returns an error so that we actually know what's going on. So that now, if we run into an error, we actually get a message that says error reading file. Okay. Look for exception as E. Nice. Okay, so I'm going to paste this into my file and add it below. Oh, look at that. I'm going to save it. And I will continue. Paste this code and save the file. Perfect. Let's go, Kahu. Yes, great stuff. All right, we just built this function, this Python script that gets all the Python files from our repo and reads it. How cool is that? Nice. Now we're going to add Gemini analysis. In this step, you're going to work out how to send prompts to Gemini. Clean up any response from Gemini. Gemini often adds annoying markdown. Parse the cleaned response into a Python dictionary. Oh, what's a Python dictionary? Write a detailed prompt with instructions for Gemini on finding dead code. Okay. We'll be building this Gemini analysis code bit by bit. You can either add to your find stale py file as you go, or wait till the end and paste it in the final function. Oh, good tip, thanks. All right. Maybe might be useful to add it in the end, and we can work through the bit by bit. Oh, look at Kaho, thank you. A dictionary in Python is similar to an array, but with key value pairs. And you can always find out more about it by just selecting this. And what is a Python dictionary? Look at that. What is this? I could say. And it would tell me exactly what Kaho said. It is a built-in data type that stores data in key value pairs. And then you can ask more. What is a key value pair? And it's unordered, mutable, indexed collection. Each key must be unique and it maps to a specific value, allowing for efficient retrieval of data. Nifty little function, right? The ask. It's like someone who knows exactly what you're doing and can answer all your questions right there. Okay, so let's start with the skeleton code. Read the following code block. This is a skeleton code, placeholders that help us understand the high-level tasks. Okay, if you'd like, paste this code below, or you can wait till the end. What are we gonna do? All right, so let's take a look at this skeleton code we have here. Define and analyze code with Gemini. So we've got input, code content, and a file path. Both of them are strings, and it outputs a Python dictionary. Then we've got all these things to do. We've got to write the prompt, send it to Gemini with the files. We have to get response and clean it up, and then parse and return. All right, 4 things to do. Let's do it. How do we send things to Gemini? Oh, we're going to start with this one. Look at that. Okay. We're going to ignore the prompt itself for now. All right. Okay. How would we send any prompt to Gemini? Ooh, okay. Thought. Food for thought. All right. Can you spot the new content here in the code block? Yes. This is the new content. Oh. Okay. How to send things to Gemini. Okay, so that's the second one, right? Okay. And then how would we send any prompt to Gemini? Got it. got it. I just had to read it one more time to understand. Can you spot the new content? Yes, I can. Let's go through this. So this is the first to do. And this is the second to do. And the second to do is sending any prompt. How do we send that? Oh, okay. So we're going to save. So we're going to create something called response. And we're storing a client.models.generate content model and contents equal prompt. What does that mean? Let's take a look. We finally return this response.text. What is this piece about? Remember Gemini client? Yeah, I do. It's right here. Can you spot the use of client models? Do you remember in step 1 we created client equals Gen AI client? Yep, I remember. We're using the same client to send our prompt to Gemini for analysis. Okay. This code will return a response from Gemini in plain text. Aha, it's a good start, but not very useful for our purposes. We need the response in a structured data format so we can separate it into nicely formatted issues. All right, so this is a good start, but there's more. Okay. So now we're going to do the third to do, which is clean up Gemini responses. The first problem with Gemini responding in plain text is that Gemini will often wrap responses in markdown code blocks. This will break our future parsing and stop us completely from putting our responses in a data structure. Hey, did you write this project for me? Like, Maya gasp is iconic. That's my signature. And it's like, I just gasped on cue. Let's make sure we don't have any funky markdown formatting. All right, that's what this function is about. So define analyze code with Gemini. We've got 2 inputs. Output is a dictionary. This is all the stuff that we had before. This is the new content. Okay, this is the part that we are removing. We're removing code blocks in Gemini. And response text. So we store something that we take something, we strip it off, maybe the white spaces, the blank spaces maybe, and then we store it in response. And then we see what starts with, oh, the typical markdown formatting, yeah, and then we split it every time there is the closing. And so we're just removing that, kind of parsing a string so that it's cleaned up. Very interesting. Yeah, how the heck does this cleanup work? Yeah, okay. So split \n1 basically says split the string at the new line character 1 time, okay? And rsplit splits the string from the right side. So going from the right at the last 3 backticks 1 time. Cool. Awesome. We now have a clean text response returned from Gemini. How cool is that? It takes the text, goes through the whole thing, and cleans it up. Nice. Very cool. All right. Now let's make sure we run a Python dictionary. The problem with returning plain text is that we can't easily group information in the response into things like type or line number. We'll need this to write our issues. A Python dictionary is one possible solution. It lets us access data with simple syntax. All right, let's take a look at our cleaned up responses and put them in a Python dictionary. Let's look for new content here in the code block. All right, here's the new code, the new function. So we have our first to-do still. We haven't written the prompt. This is our second to-do. This is the third to-do, and this is our new piece, which is simply returning JSON.loads response text. It converts JSON string into a Python dictionary. I just thought of the quiz question that we had, and it was a question on how do we load the JSON string. So I suppose the right answer was loads, not load. Oh, interesting. Very interesting. Very cool. JSON.loads converts any JSON string into a Python dictionary. This means that we can take Gemini's response, clean it up, and then store it in a Python dictionary as long as Gemini's response is in the format of a JSON file. Exciting. Exciting. Can we copy the whole thing in there yet? Nope, not yet. Now we actually have to write the prompt. Okay. All right, what's the prompt that we're going to write? So we start by adding the F double quotes syntax after the prompt variable. So this is the prompt variable that we're creating. And we add our prompt as text because it's not Python, okay? This is where we put our prompt. What is this syntax? It basically means it's a formatted string, and it lets us insert variables like file path directly into the string. The triple quotes allow multi-line strings without needing escape characters for each new line. Okay, so we have this piece, we have the structure, but we still don't have a prompt. Let's build our prompt bit by bit. Feel free to add your prompt into your code as we go, or we'll get the fully combined version. All right. First task is to ask Gemini to look for dead code. Remember what those three types of dead code we're looking for? Unused functions, dead imports, unreachable code. Unused functions, dead imports, unreachable code. We're literally telling Gemini to look for them. So we look for, so this is our prompt. And that is what we're going to put in our, in here, okay? Okay, so this is the prompt. And then we have file, and then we have code. So we are giving Gemini the file, and we're also giving code content, the file path, and then the code content, right? Now we want to make sure that Gemini responds in a JSON format. So we need to tell it to respond in a JSON format. And so that's part of the prompting. Respond in a JSON format. Let me expand this. Respond in a JSON format with this structure. So it should be stored as findings, and it's got type, it's got name, it's got line, it's got description. So type is it an unused function? Is it a dead import? Is it an unreachable code? Name is the name of the function. Line is in what line of that code it is, and a description of why it is dead code. Okay, cool. We're actually telling AI to do stuff for us. And this is such a structured, clean, very well thought out way of telling AI to help us with a task, with a trivial task of finding dead code. Cool. Very, very cool. Lastly, we need to explain to Gemini what to do if there's no dead code to be found. Should we return an error? No. Just, Gemini, just tell me here. Just no additional text, just return an empty response saying that if there's no dead code, return only return the JSON, no additional text. So don't give me error, don't give me like panic attacks, none of that. We just stay calm and say, no dead code. All our code is alive and thriving. Okay. Now we put it all together in our function. Wow, this is the code that we just built step by step. Whoa, hold on a minute. All right, wait a minute. Let me follow. Okay, so this is the entire function. This was the first to do. Oh, and so you see the need for the multi-line code. So this entire F string is super packed in there, and that's all just the prompt. Wow. Okay. Oh, right. So that's the prompt. And then we have all the 4 to-dos right here. Very cool. So we prompt it, we send it to Gemini, we clean it up, and then we load it and convert the JSON string to Python dictionary. Wow. So exciting. All right. Oh, I thought we were done, but no, we're not. We need to worry about error handling. Okay, no worries. We'll get there. Hold on. All right. How is this going? Did I format everything correctly? Hold on. Oh, how do I, is there a quick way of removing that indent? There's got to be a quick way. No? What's the cursor tips? Anything? Okay, I think we're okay. Cool. All right, this is my new code, my new function. And we copied everything, all the 3 to-dos. Exciting. All right, hold on. We have to think about error handling. Error handling. We'll put our calls to Gemini in a beautiful try except to catch any errors. This is the final code. Can you spot the error handling? Oh, I think I copied too early. Let's see. What am I looking for? The error handling. Okay, so we have all this, and right here we have up to this. Yeah, if no dead code is found, return findings and only return the JSON, no additional text. That's part of the prompt. And then we have a try and catch. So try, and if there is nothing, if we receive nothing, if we get an empty list, it's return as error. Is that right? Did I understand that correctly? Paste this code into the find stale. All right. Does this have everything or no? Maybe I can just copy the difference, or I can copy this and replace this entire bit. All right. How's that? How do we do? We now have 3 functions, and the third one is intense. All right. Does everything look okay? Hello, hello. Good morning, Rajneesh. All right. I think I would want to indent this piece, right? So that it's included in the definition, in the function. All right. How does that look, team? All right. I think we did it. All right. I'm going to hit save. Exciting. Exciting. Okay. And we can just check and make sure that it looks okay. We read the file. Oh, that's from here. Yep. Analyze code. And then indentation wise, oh, you could even indent this further. Yeah, that would make a lot of sense actually. It would be nice to read. It would be nice if that indentation was here as well, wouldn't it? Okay. Cool. All right. A lot of code. Okay. Shall I take a picture of this? Does it look okay? I'm still feeling a little. Yeah, it's a lot. It's a lot. Okay. Yeah, it's wonderful when you try and understand the code. Okay, so what does the JSON loads function do in the analyze code with Gemini function? So the JSON.load function converts a JSON object to a Python dictionary. Okay. Oh my goodness, we're at step 3. This is so exciting. Exciting. Nailed it. Aw, thanks, Vano. Okay, let's build the scheduled workflow. All right, let's complete the script and automate the stale code detection with a GitHub Actions workflow that runs weekly and creates issues with findings. In this step, you're going to add the markdown formatter function, add the main function to run the detector, create a GitHub Actions workflow file, and set up automatic issue creation. Oh my goodness, I'm going to do a lot. Okay, I'm going to add the markdown formatter function, add the main function to run the detector, create a GitHub Actions workflow file, and set up automatic issue creation. This is important. This is important because I want to automate. This is important. Why is this important? Hold on, let me add some correct punctuation here. Whisper flow, it was a list, had to be comma. Okay, I'm going to add all of these functions because these functions will be part of the script to automate the stale code detection. Okay. Done. Let's check it out. It's looking good, huh? It's looking good. Okay, add the markdown formatter. This function converts the findings into a readable markdown report for GitHub issues. We'll be building this function bit by bit. You can either add to your find stale file as you go, or wait till the end and paste in the final function. Okay, same process. We're going to build it little by little, function by function, and at the end, we'll add the whole thing. Okay, we start with a skeleton code. Skeleton code is it's just going to tell us what we're going to do. So let's take a look at it. We've got this function that we're going to create. It's called format findings as markdown. And it basically takes an input, which is a dictionary, a list of dictionaries, and outputs it as a string. So it formats all findings as markdown for a GitHub issue. What are we going to do? We're going to handle empty findings case. We're going to create markdown header with count of, group findings by type, right? And generate markdown for each group. Whoa, this is jam-packed. What are the high-level tasks? We need to check if there are no findings, count the total of findings, right? Group them by the type. So like there's going to be 3 unused functions or 2 dead imports, and then we build that into a markdown string for each group. Handle empty findings and create header. Can you spot the new code we're adding? Look for the comments that match our to-dos. Okay, what is the first thing that we're going to do? The first thing is we're going to handle empty findings case. If not all findings, return stale code report, no dead code detected in this scan. Okay? And then create a markdown header with count. So markdown, we have it, call it stale code report. And then we add it to the string. So that's what the plus equals means. We add a string to the existing string, and we add found all potential issues. And this is the length function, and it's going to give us a length of the all findings list. So it'll count how many items there are in the list. That would be a number. And so it'll say found number of potential issues. Ooh. New Python concept. Dun 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 dun. We need sound effects in this in the projects. That'd be so cool. New Python concept. Length of the list returns number of items in the list. For example, length of the list 1, 2, 3 returns 3 because there are 3 items in that list. Great. Now we have the header sorted, but we need to organize our findings. That is correct. How do we organize our findings? Group findings by type. The problem with dumping all findings into one list is that it's hard to read. Let's group them by type. So unused functions, dead imports, and unreachable code each get their own section. All right. By type. And so this is a new object which is called by type, and we're doing a for loop. We're going through all the findings, and for each finding, we're checking what's the type. If finding type not in by type, okay? So we're actually adding all this into by type, okay? If finding type not in by type, then add that into there. Ah, cool. So we start with like an empty structure, and then every time we run into a type, we add it to that. So you won't see all four, you'll only see whatever's in there. That's an efficient way of doing things. New Python concept. Can we get that sound effect again? Dun, 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 dun. Or is it? Oh, I want to know what that sound effect looks like, Pano. I don't even want to try it, but it sounds really cool. And I hope you'll be able to demo it for me. Awesome. Our findings are grouped by type. Now it's time to turn them into readable markdown. Okay, generate markdown for each group. Finally, we loop through each type and build the markdown output. Let's go through this. Okay. Type labels, unused function. We give it the name unused function. Dead import, dead imports. Unreachable code, unreachable code. So we've got labels for all our types. And then for each item, we go through it, we look at the label, and we give each item a label and keep adding a label to our markdown file. Wow, how cool is that? And we have got a for loop that goes through each item in the findings and keeps adding the type into that. Nice. Okay, using .get. Ooh, this is, okay, why do we need .get? And why are we using .get for our labels? Great. Notice type labels .get, finding type, finding type. If the type isn't in our labels dictionary, we just use the raw type name as a fallback. Oh, that is cool. So sometimes if we, like right now, we've set it up so that there are 3 labels and 3 finding types, but maybe we in the future might add more finding types. And then if we don't update this piece of the code, then we might have more. And then we want to at least fall back to the raw type name. And that's what this does. So cool. Nice. All right, this is the complete function. We just broke it down all together. We broke it down one by one, and now we're going to put it all together. All right. Let's paste this entire thing into our last bit. Okay. Putting it here. This is a massive Python file, and we just went through that step by step, function by function. Isn't that cool? Like, wow, I actually know what this code is all about. I'm not just copying and pasting blindly. Wow, amazing. Add the main function. Of course, we need a main function for this. Add the main function that orchestrates the entire scanning process. Let's start with the skeleton code. Read the following code block. This is a skeleton code. Placeholders that help us understand the high-level tasks. Okay, this is how we're going to do it. So we start with just the main function. And the idea is that we're going to scan the repository and report the findings. So in the main function, we need to get repository path, we need to find all Python files, loop through files and analyze each one, and then generate and save report. And finally, we will return all findings. What does the main function need to do? This function ties everything together. It finds files, analyzes them, and creates the report. It's the conductor of our script. All right, so let's find all Python files. So in this, in the main function, we're going to start with a repo path that takes in what our GitHub workspace. And then, yes, sci-fi, it is live. Follow along, join us. We print a string scanning repository, and that has our repo path. Very cool. And then we take all the Python files from our repo and we save it into this, and then we print the statement that says found 5 Python files, whatever the length is of that list. And then we loop through the files and we analyze each one, and then we have to generate and save the report. So this is the first piece where we scan the repository and report the findings. Very cool. Calling your own functions. See how we call get Python files repo path? Yeah, we wrote that, didn't we? We did that. So the main function is calling all the functions that we've written. And it's going to do it step by step. And it's going to package it super nicely so that it has statements that are printed so that we know as an end user what is happening as these functions are called. And then we pass each function with our required arguments. Very cool. Great. We've got our list of Python files. Now we need to analyze each one. Loop through files and analyze. This is where the magic happens. We loop through each file and send it to Gemini for analysis. Oh, whoa. All right, so this is where we create all findings, and then we're looping through each one of that file. And how nice that every time we do something, there's a print statement. So we will know what's happening. If we didn't have this print statement, we wouldn't know what's happening. We would just have no idea. So all the print statements aren't absolutely required for our code, but it's a nice touch to make sure that we are aware of what is happening in the code. Very cool. So we're analyzing the file path, and then we look through the content, we read it, and if it starts with error, we're going to just skip it. And then if that happens, we just keep going through the for loop, another iteration of the loop. Cool. Very cool. So it keeps adding to the content. If it starts with error, we skip it and continue. And then this isn't part of the if. Right, so result equals analyze code with Gemini. So what continue does is it skips all of this. So if we have content that starts with error, what will happen is it'll say skipping, and then it will not do any of this, and it will just go back to the for loop and do another iteration of it. But if it doesn't start with the error, it will do the remaining things. So it will store that content into the result, and it's another method, it's another function that we've written with exactly the inputs that we've told it that we wanted, like a string input and the file path, and we pass that onto this function, and whatever the output is for this function, which is in this case we return, what do we return here? We return a dictionary. Oh, yeah, here. We return the dictionary. I'm a little skeptical about the indentation. Should this be indented? No, it shouldn't. Okay. Yeah, so finally it returns a dictionary. Yeah, very cool. And that's what we do here. And if error in result, then you print. So if after doing that, we've got a error in the result, then you print analysis error, continue, and then you go through another for loop, findings, go through each finding, each file path, and then append it. Wow, very interesting. And you know what? If you want more detailed explanation about it, you can just click this little popping, jumping little icon, and you can get all the entire explanation for it. Ask all the questions you want. Why is this happening? Why do we do this? What does a continue mean? What does enumerate mean? What is going on? Just ask. All right, so yes, we are reusing our functions. Yep, that's the one we built in step 2, and we're adding it here and calling it and adding it to our main. How cool is that? Whoa, nearly there. We've collected all our functions, all our findings. Now we're going to generate a report and save it. Whoa. All right. What are we going to do? We're going to generate and save the report. How do we do that? We create a new variable markdown report, and we store everything that we get the return from this. What was this? Was this a finding? Was this a function we created? Yes, it was. And this is the function that we created to format all the findings. Oh, so we store all of that into the markdown report, and then we print it. What are we printing? A new line equals times 50. Oh, we do that 50 times, and we print the markdown report. And then we open, and then we store it, and we write the markdown report in this file. And now we've saved our markdown file, return all findings, and then if in this name we have main, then findings equal main. Okay. What is if name equals main? This is a Python pattern that means only run this code if the script is executed directly, not imported as a module. It calls main and exits with code 1 if findings exist, indicating issues found, or 0 if clean. Done, right? Actually, yes, the main function is complete. Whoa. Shall we add it? This is massive. Look at that. We just went through this entire code step by step, starting with a skeleton code, breaking it down, really understanding what we're doing. Very cool. Poof, that is huge. Super cool. All right, sci-fi. Sci-fi's back to pick up Roy's quote from yesterday. Ooh, share with us. What is this quote that you picked up? What is this quote? Quotable quotes of Roy's. Do remind us what Roy's wise words were. All right, let's create the workflow file. All right, now for the exciting part. Let's automate the stale code detection with a GitHub Actions workflow that runs every week. Okay. Open the GitHub Workflows folder, right-click New File, and name it Stale Code YAML. So GitHub Workflows, right-click, New File, Stale Code .yml. Enter the workflow configuration. What is this? Oh, sorry, I can do that. Or I just want to check through. Ooh, I remember this from the quiz. So we've got stale code detector. Every Monday, it's going to run this workflow. It also allows for manual triggering. And these are all the things it's going to do. Tell me more. So the cron syntax means 0, run at minute 0. 9 is run at 9 UTC. Any day of the month, any month on day 1. So it's minute, hour, day, month, day of the month, and then the weekday. The day of the week. Trigger is schedules, runs automatically every Monday at 9 a.m. We have a workflow dispatch. Allows you to manually trigger from GitHub Actions UI. And permissions needed to check out the repository. All right, okay, let's save this. I'm gonna save it. Okay, dokie, let's take a screenshot of this, shall we? Let's take a screenshot. Okay, that's all I'm gonna get in this bit. Oh my goodness, have I told you guys how much I love the ability to just take the screenshot and just hover and paste? Ah, beautiful. How cool is that? Oh, what does the cron expression 09 * 1 mean? The cron expression runs the workflow at 0 minutes, 9 hours UTC. What was the first one? Any day of the month, any month, and first day, or actually second day, because 0 is Sunday, right? And then so Monday, and then on a Monday. Done. If I wanted, I could add an extra tip like 0 is Sunday. All right, great. The workflow is ready, but we need to create some labels to organize our issues. Oh, why do we need labels? Labels help you filter and organize issues. Let's create 2 labels so our automated reports are easy to find. Go to your repository on GitHub. Uh-oh. Okay, let me pull up my GitHub repository. Oh, you know what? I had deleted all my caching and all of that. Let me quickly sign in. Uno momento, please. What's everyone chatting about? Sci-Fi says Roy's comment about his work at the Brooke Army Medical Systems. Um, that's why he's come back for the comment. And Shane says, I think it was don't do the secret missions. Was that the comment? Maybe I'm reading it out of order. Let's see. I feel like I worked in so many places. I feel honored. Aw, nice. Good to see you. Good to see everyone chatting. I know Roy's doing the project, Shane's probably doing the project, Sean's doing the project. Sohib, are you doing the project? Amar? Ooh, I might have missed the memo, but how often do you do these lives? Well, we released 21 projects in 21 days, and we actually did live every single day of that 21 days. So, yeah, I hope that answers your questions. Stay tuned. If you check out the events section of the Discord server, you will know all the upcoming events and you can subscribe. All right, and there's no subscription, like you can't actually subscribe, but you can just follow. I usually send out an announcements as well, so you'll know when we've got events coming up. All right, create the tech debt labels. Labels help you filter and organize issues. Let's create 2 labels or so. Let's create 2 labels so our automated reports are easy to find. Go to repository on GitHub, click on the issues. Am I supposed to have issues? What if I don't have issues? Interesting. Okay. On my labels, click labels on the right side. The right side, okay. Whoa, I think I'm on the wrong place. Where am I going? Hold on, so here, hold on. So we are in AI CI/CD GitHub. Next to my code, I should be seeing A issues, but I don't. That's okay, I just need to find it. Perhaps this isn't the issues that I'm looking for. Oh, did I push to main? No. Was I supposed to push to main? Did I miss something? No, we're just creating labels. We haven't pushed anything. But I cannot find the place where I would create labels. Might be in settings, the settings of my repository, or here. Tags, no issues. No. Where are the issues at? Where are you, issues? I'm looking for you. Looky. Playing a game of hide and seek. Okay, so I see issues, but then I see assigned to me, created by me, mentioned. but I don't see. Click on the Issues tab, and there's supposed to be labels. Go back to your repo. Okay. All right, this is my repo. I'm supposed to see issues here. I don't see issues. What am I missing? Was I supposed to do something else with my Git repo? Is it possible that it's part of the previous projects that I didn't do? Oh, look at that. It's hiding over here. Why is it hiding there? What? What? Is that it? No, no, that's not it. Issues? This is funny. All right, let's see. Settings. Search for issues. This settings or this settings? I've learned that both are different. Okay, settings, and then I'm searching for issues. That. No, wait, hold on. Command F search? No. No. What? It says there's 3 and I don't see it. What am I doing? What's happening? Scroll down, you'll see it. Okay. There's nothing to scroll down. I don't know what's happening. Um, issues. Does everybody else see issues? Is it just me? Oh, look at that. Is this it? Features. Oh, now it comes up. No, wait, maybe I have to save it. Do I save it? Yep, that's it. Yes. All right. But how do I see it? Do I refresh? Okay, always. The search. When in doubt, when you can't find something, when something's not working, just refresh. Aha! There it is. Woohoo! Thank you, team. So exciting. It was a little bit of a scavenger hunt there. Woohoo! So pesky little issues hiding from me. All right, so now we're in issues, and then we click on labels, click on new label. Ooh, and we're gonna call it tech debt. Dun 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 dun. Create label. Ooh, I can choose the color of your choice. All right. Create label. Create another label named automated. Ooh, tech debt and automated. What are we doing with these labels? I'm intrigued. Ooh, and this is neon green. Automated. That sounds about right, actually. Neon green for automated. I choose that. And perfect. Labels are ready. So we've created 2 labels, and voila. Time to push everything to GitHub and see it in action. This is it, guys. Oh my God, we've built this code, we've created all these functions and done all these things. Now we're gonna push it to GitHub. Whoa. All right, so this is our commands. Let me go back to cursor. All right, let's do this. Let me create a new one. And I'll push my changes. Everything saved? Okay. It's writing objects. Okay, it's been pushed. How will your stale code detector run without manual intervention? Oh, the detector will run automatically because of the amazingly beautiful Python script I created or wrote, I designed, that reads all the files, reads the files from my Git repo, reads it, sorts it or categorizes it, sends it to Gemini, or yeah, so much. We just did so much. Reads the file, uses, wait, hold on. Detector will run automatically because of the script, Python script I wrote that reads file, uses Gemini to determine if there is dead code and categorizes it for me. Whoa, how cool is that? Ah, I'm so excited. Whoa, what a journey. Yeah, you finished the script and created the automation. Here's what you have now. Our markdown formatter, which converts findings into readable report grouped by type, main function, GitHub Actions workflow, labels. We did a lot. Now we're going to actually verify the workflow. Oh my gosh, this is it. This is the part where we find out if it's all working. Exciting, exciting, exciting. Let's test it, shall we? Let's test the workflow by triggering it manually and verifying the issue gets created. In this step, you're going to manually trigger the workflow. Okay, I'm going to manually trigger the workflow and verify that it is working. This is important because I need to understand the workflow output. Oh, you know what? You know what's really cool? Suppose I add this and then I take a look at the documentation and I see it and I'm like, oh, I'm supposed to, no, you know what? It doesn't look right. There's supposed to be a space. I can add it right here. How cool is that? Let's see that document. You got that right, Roy. I'm happy to show you my beautiful, beautiful documentation. Look at that. Can't wait for the final. All right, all right. All right. Okay, so now we trigger the workflow manually. Instead of waiting for Monday, yeah, Monday's too far away, guys. Instead of waiting for Monday, let's trigger the workflow now. Navigate to GitHub. I think I have GitHub open. Where are you, GitHub? Okay. Click your profile icon in the top right corner and select your repositories from the drop-down menu and click on your CI/CD GitHub repository. Oh, I could have just, I think I'm right here. It's right here. Okay. And then click the Actions tab in the top nav bar. Right here. Hold on. Put it on the left and this one on the right. Makes it easier. Okay. Click the Actions tab. We've done that. Select Stale Code Detector. Wow, that's our workflow. Because we pushed it. Wow, look at that. This is exciting. Okay. Click Run Workflow. Yeah, click Run Workflow and select the main branch. Click Run Workflow again. Okay. Oh my goodness, I feel a bit nervous. All right, running workflow and then click Run Workflow again. Did I click it? Did click it? Did I click it? Yeah. We just clicked it. It's running. It's running. Oh my goodness. What are we doing? Oh my goodness. Oh my goodness. Okay, okay, okay. Contain the excitement, Maya. Contain the excitement. All right. Watch each step complete. Check out the repository. Set up Python, install dependencies, all of that. How do I check out what's happening? Hold on. All right, so it took 14 seconds. It ran a minute ago. View workflow file. I think it ran successfully. Yeah, because I've got a green tick sign. It ran. It completed. Whoa! Did it work? Oh my goodness. Oh my goodness. Oh my goodness. This is exciting. Yay. All right. Oh, let's go. Yeah, we did it. We clicked it. Oh, it's happening. Oh my goodness. Oh, you guys are so sweet. Check the created issue. Okay, so now we click on the workflow, run to see the details once the workflow completes. Okay, so let's click on this. Click on this. On the YAML file? Where we, hold on, 1 second. Okay, yeah, we're here. And then expand the logs to see the create GitHub issue. Expand the logs. Where's the logs? Here? Oh, look at that. Look at all the things that happened. Whoa, okay. I wonder if that's what I'm supposed to see. Hold on. Let me play around and is this the workflow file? This is our file. How do I see what I see in this screenshot? The workflow logs. I'm looking for the workflow logs. Expand the logs to see it. Is that the usage? Oh, hold on. Oopsie daisy. Okay, we ran it twice. I see I got a little too click happy and I clicked it twice. All right, so I click on this and this is the log, right? And then I want to, maybe if I open it up, I see it. Okay, there you go. So create GitHub issue. And I don't have a check mark. Oh. Go to the Issues tab in your repository. Hold on, this is, I ran it twice. I'm just going to check the first one as well. Okay, and both times the create GitHub issue isn't a check mark. That's okay. Let's go to the issues in the repository and open the new issue titled Weekly Stale Code Report. Oh no, I didn't get a report. Uh-oh. Uh-oh. Okay, that's okay. Time to debug. Time to figure out what happened. So here in my actions, oh, look at that. Okay. Oh, this is from a few days back. Here it says everything ran correctly, but the create GitHub issue didn't happen. Why is that? So we set up the job, install dependencies. Okay, we did all that. Run stale code detector. And here, oh, can't open AI CI/CD GitHub. And then it's there twice, scripts find stale. Okay, let me go back to my code. Did I store it in the wrong place? So under workflow, I've got stale code, but find stale is inside scripts. No such file or directory. Oh, it looks like it's duplicating one of the path sections. How do okay, so if it's duplicating one of the path sections, where can I go to fix that? Where would I have set that up? Is it in my workflow? Let's see. So I have my workflow, and here I have scripts find stale, which is what I want. Oh, good point. Good point, Kahu. I think you're right. Let me rename this. Okay, let me push it again. Let me save it. All right, let me push it again and see if that works. Okay. This time I'm adding a stale code detector with weekly workflow, and here added the hi file. Yeah, okay, I know what that means. Okay, all right, shall we go check it again? Okay. All right, let's see. So now let me go back to actions. And this is what I just pushed, which is working just fine. And now I need to run this again. Okay, let's run it. Okay, it's running, it's in progress. Let's check it out. Let's check out what's happening. No, no. Okay, at least now we have a different error. Expected an indented block after function definition on line 24. Okay, okay. Let's go to line 24. Oh, this part, yeah. Okay. Would that be it though? Try, accept. That can't be it, can it? Okay. One more time. What is the error again? Read and return the content of file, line 25. Okay, everything else looks okay? I think so. Okay, let me try it one more time. One more time. Third time's the charm, I tell you. Third time. Okay. What do we do? Added the indent. Indent. Okay. All right, I pushed it. Is it there? Is it there? It's there. And it's building. All right, what's happening? Okay, it's built. All right, let's go back and stale code detector. Run this workflow again. Third time's the charm, guys. This one's going to work. I know it. I know it. All right. Just refresh. Okay, number 4. Okay, so this is misleading. I'm not falling for it. Oh no. What's the error now? Another indentation error. I wonder if there's a way I could verify the Python files are compiling before I push it. Is it? I think this is supposed to be indented maybe. Let me go back and check the file. Let me go back and check the code. So this is for the read file content. Read file content, let me read file content. Okay, it's after this. Yeah. All right, so what can I do with the indentation? What am I missing? Try with open, we've got the return, and then accept is in the same indent as try. No, it looks okay. Looks just fine. What's the error again? Unexpected indent. Unexpected indent. You know what? I'm just gonna try something here. I'm gonna take a screenshot of this and see, hey, ask, does this code look right to you? Yep, it looks correct. Different line in the error, I think. It's line 63. Oh, gotcha. Fair enough, sorry. Line 63. Oh, yes, maybe. Let me go back. Okay, let me check the code. This is the analyze code with Gemini function. And let me check the last one. Okay, this is putting it all together. And then here, let me expand that. And when I expand it, oh, this one doesn't have the try catch. 1 second. When I expand this, Sean has an idea that I copy this whole thing and then paste it here and see if that would work. How about this code? Oh, look at that. It formats it. Wow. Who built this beautiful app? Okay, ready? Whoa. That's so cool. Look at that code just automatically beautiful formatted. Okay, the code contains several functions. What about indentation? Does it match the project guide? Okay. All right. All right. I'm going to call a lifeline. Community, I need your help. We're going to do this. We're going to figure this out together. That's the best thing about the Build Labs. All right. Line 63, at the try, there's an unexpected indent. Ask says, I am perfectly fine, but I'm going to have to bring out my troubleshooting cap on and look into this error. Line 63, but sometimes even if it says line 63, it's probably line 62. Oh, is it this indent? Oh, Kahu says, did you try this? You can try Python's indentation compilation. All right, so do I run that in the terminal? Arguments, following arguments are required. Compile, and then, oh, sorry, you had the find, okay, hold on. Find stale dot py. Okay, maybe I have to say, I have to specify that I am in this, in scripts. Unexpected indent, well, that's what I'm trying to figure out. Okay, I think it's this one. I think this is one extra indent. But how do I take this entire code and remove the indent of that whole thing? Oops. Okay. I want to, we have try and accept, and I think we want it in this line. Press Shift Tab to indent the left. Shift Tab. Shift Tab to indent the left. Oh, cool. All right. I think my Indentation should be okay now. It looks okay. I think so. Let's run this line again, shall we? Oh, oh wait, I have to save it. Silly me. One more time. Yay! Okay, no more indentation error. And now we push it again. Fixed indentation error. Okay, ready? Let's go, let's go, let's go. Okay. All right, running. Yes, I'm on my way. I'm getting it. Shane, Roy, how's it going? I know you guys are doing the project. Do I already see it in the celebrations? Are you already done? Let's go. Okay, actions. It's running, looks good, and I'm going to go to Stale Code Detector, running the workflow. Run it. And I'm going to refresh because I have no patience. I just want to see it. Okay, there it is. I'm holding my breath, holding my breath. I think we've gotten further than we had. Hold on, hold on. We're doing it, we're doing it. Okay, okay, okay. Almost, we're gonna find out. Whoa, look at that. There's a check mark next to GitHub, create GitHub issue. Wow, wow. Where's the confetti? Where is the trumpets? Where are the doves flying? I am so excited. What is... Wow. Wow. There you go. I love it. You guys are awesome. Get those trumpets and doves going. Yes. Yes, we did it. We did it. We did it. Okay, now what? Oh, I'm so excited. I'm so excited. Okay. Where are we? Verifying the workflow. Almost there, almost there. Oh, yes, look at my beautiful. Okay, wait. GitHub issue. Let's go to GitHub issue now. Yes, I see this check mark. Woohoo. Let's go to Issues tab. Issues tab. Okay. And then, whoa, we have an issue, guys. We have an issue, and it says Weekly Stale Code Report. And it's got today's date. Whoa, this is huge. We did that. Yeah, we did. Look at that. The issue should contain a summary of how many issues were found. Oh my goodness, look at that. All that code, all that functions that we created on the first project, it's saying it's stale code, it's dead code? How rude. Why? Why is that dead code? Because it's unused. That's right. It was, and look at that. It gives you the explanation because we did that. We wrote the function that gave us an actual report that tells us what type of dead code it is, why it is that dead code, the name of the function, the location of the function, the explanation. We did that. That's amazing. And yeah, it tells you a really good explanation. That's Gemini analyzing the function, saying why it's dead code, providing an explanation, putting it out in a report. Beautiful. Add, because it's never called, even never called, reverse string never called, multiply never called, dead inputs time. That's not used anywhere, so that's dead too. And look at that, we just cleaned up a bunch of code. It just told us it just helped us find all this dead code. Whoa, exciting. Of course, I will give you a screenshot of my beautiful report. I would love to do that and then put it in my documentation. And now I have to check out my documentation. Wait. I got one more little question to answer. What does the stale code report in your issue contain? Oh, the report contains findings for all the unused functions, including where it's located, the name of the function, what kind of dead code it is, and why it is dead code. Wow. And now we're going to check it out. Look at that. My beautiful issues report is now in my documentation. Hold on. I just need to take like 5 seconds to admire it completely. Look at this. Just look at this. Wow. And this beautiful screenshot is there. Exciting. All right. Understanding the results. You'll likely see findings for the functions in in app.py. These are the functions that we created in the first project, and they're showing up as dead code because it counts. It doesn't help with our production usage. It doesn't really count as production usage. So because it's never called and that they don't have any purpose, it actually is dead. It's just dead code. Why might the detector flag functions in app.py as dead code when they're actually used? Oh, even though they're actually used in the test, the detector flags these functions because these functions serve no real purpose, and so it is considered as dead code. Wow, so now we also have set it up in a way that our workflow will run automatically every Monday. And every time I push new code, I will always, on Monday, get a report of all my dead code so that I am aware. I can also manually trigger it. Wow, epic work. I agree, it is epic work. You've verified your stale code detector is working. We've confirmed that we've got manual triggering. We've got issue creation. We've got false positives. You understand why single file analysis flags some code. Oh, you understand why single file analysis flags some code incorrectly. Your automated tech debt detection system is now live and running weekly. How exciting is that? Epic. Whoa. Now there's a secret mission where you can estimate the cleanup time for tech debt. Wow, what an unlock. So not only will you get a report of your tech debt, but in the secret mission, you can estimate the time it takes to clean it up. And that might be really useful. I might have to skip that one today, but let me know if you complete it and tell me all about it. All right, we're going to clean up the resources. What do I want to do? Do I want to keep everything running? If that's the case, no action is needed, but there might be a Gemini API cost. There is a generous free tier, so maybe I might still be within limits. Okay, good to know. I could disable scheduled runs. Yeah, that's actually a good idea because I like my work, but I don't want to use Gemini credit. So how do I turn this off? If you want to stop the weekly scans without deleting workflow, you can edit the stale code YAML file and comment the schedule section by simply putting a hash. Okay, let's try that. So in the stale code, we'll go to our on, and then we comment out schedule, and we comment out cron. And I'm also going to put a little comment here. I'll say disabled so that I remember that I have disabled it. And if I want to enable it, I can enable it later. Okay, so I've saved it, and now I'm going to commit and push the changes. I've got a nice little commit message already written for me, so I'm going to copy and paste that. And voila. Voila. And if you wanted to remove everything, there's a whole step-by-step guidance on how to remove that. But other than that, I think we're done. That's a wrap. Whoa, you did it. You've built an automated tech debt detector that scans your code base weekly and reports findings as GitHub issues. The key tools I used include, wow, I used a lot of key tools. I used Python scripts. I used Gemini model. And then I used GitHub Actions. Key concepts I learned include mainly using Python scripts to retrieve files from my repo, analyze them using Gemini, and building a automated tech debt detector. Wow, this project took me approximately a little more than 2 hours, approximately 2 hours. The most challenging part was, I don't know if it was challenging, but was troubleshooting the Python indentation errors that I had. But yeah. Why did you do this project today? Oh my goodness. I did this project today to learn how to build a automated tech detector. Another skill I want to learn, oh my goodness, is too many to list. Too many to list. And done. Whoa, beautiful. Beautiful. All right. We've got the same quiz, and yes, you built an incredible amount. To summarize, we built an entire Python script, bit by bit, step by step, function by function, and we scheduled GitHub Actions workflow. We automated the GitHub issue creation with structured findings, beautiful report, incredible champion. Yeah, we are. Yeah, we are. Here's to many more GitHub workflows to come. Task to complete? What did I miss? Oh no. Wait a minute. I didn't click done. I'm actually done. Look at that, mission accomplished. Yay, confetti. Let's go, send it, send it. All right, all right. I am going to share it with my beautiful community. Continue to, hold on, I don't want the, I just want this one. Let's see. Continue in browser. Oh, you know what? I had logged out. 1 second. Let me post it right now in a logged in account. Hold on. Hold on. Hang in there. Wait a minute. Okay. All right. I got this. In my celebrations. All right. Can you see this? Amazing. Shane is finished 23 minutes ago. Look at that. Always, always being the first one to complete. Amazing. All right. This is it, guys. Day 21 of 21 done. All right. Oh my goodness. Okay, you know what? This is a beautiful moment. This has been incredible. It has been incredible doing 21 projects with you. I've gotten the privilege of watching all of you show up every day, doing these projects, building those skills, um, leading lab sessions, leading the lab, build labs, and I want to celebrate this even bigger. I would love to take a screenshot. I know of this, of all of us who has attending this session. I know there's no cameras here and nobody's sharing their faces, but my only request is that you all smile so that I know when I take this screenshot, you're all smiling behind the camera, all right? Smile, say cheese. Okay, all right. Now we go to my browser and I paste this beautiful image of us. Thank you all for joining me today as we've completed our beautiful 21 in 21 days. This has been amazing, amazing, amazing. I've learned a lot. I'm sure you have too. If you haven't completed the 21 projects, it's totally fine. It's never too late. There's so much, so many wonderful projects here. You can check it out. Check out our 21 projects in 21 days, all listed here. I have projects I still need to complete, so join me. Maybe we can do another round of these build labs. It's been an amazing ride. It's been so much fun with all of you. Thank you all for joining consistently, for staying throughout, for writing your reviews about the projects, for posting all the errors about the projects, for troubleshooting, for going through them, for being so resilient in learning and growing with the community. Thank you all for joining. And stay tuned for the next event. If you want to run a build lab of your own, please do. It's all yours. Let me know how I can help, and let's have more of these build labs happening. Thanks all for joining wherever you're joining from. Good morning, good afternoon, good evening, good night, and we'll talk soon. Bye, everyone.